Hello, in this video we're going to be solving the following question. Given a function with input x, find the derivative of that function with respect to x, and then plug in this vector a. So in order to tackle this problem, we're obviously going to need to know how to take the derivatives of four different functions, and that is the L1 norm, the L2 norm squared, the ReLU function, and then finally the quadratic. So let's tackle those one by one. So, starting with dx of the L1 norm. So if you remember what the L1 norm is doing, it's just simply taking the sum of the absolute values of each component of x. Right, and so if we draw out the equation for the absolute value, this is a terrible line. Right, so this is the y-axis, and this goes from 0 to negative infinity, this goes to positive infinity, and then this goes to infinity. What the absolute value function is going to look like is simply this. And so the slope of both of these lines are 1 and negative 1. So with this in mind, what we know is, well, if we take the derivative, okay, I'm going to move this line down. Sorry about that. Here we go. And then I'm gonna clean this up real quick because this is not true. dx. Okay, so this needs to move over here. With this in mind, well, if we start taking the derivatives of each one of these sum terms, what we'll get is a vector, so d dx1, d dx2, dot, 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 right? And the actual derivative of each of these terms is, well, it's going to depend on whether or not x is negative. If it's negative, it's going to be negative 1. If the value is positive, then it's just going to be 1. So I kind of said it out loud, but that just basically means that the derivative of this is the sine of x, right? So it's negative 1 if x is negative, and positive 1 otherwise. So that's the first objective. I'm going to erase all this and simplify it. Here we go. Sine of x. Now, d of dx of the L2 norm squared, it's actually quite simpler. So this is simply d of dx of the square root of each component of x squared, right? And then we square this function. So this right here is the L2 norm, right? This is x2, and then we're squaring it. So what happens with that is, well, this just becomes d of dx of x squared 1 plus x squared 2 plus dot, dot, dot. I keep doing this. Plus xn squared. And, well, taking the derivative with respect to each component of x, what we simply get, so if I take the derivative with respect to x1, so we say d of dx1 of x1 squared plus x2 squared plus dot, dot, dot plus xn squared. Well, this is just simply 2x1, right? Because all these get zeroed out. So if we take the derivative with respect to x, the whole vector, well, we get that this just becomes 2x1. For the derivative with respect to x2, it becomes 2x2, dot, 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 which this is just equal to 2 times x1, x2, dot, 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 xn, which is just 2x. So yeah, that's the derivative. Super simple. Okay, so bam. So we've just done half of the derivatives. Easy peasy. So now we have the least trivial objective, and that's the ReLU function. So the d of dx of ReLU of wtx. So actually, I'm just going to do x for now. Let's just say x, and then we'll solve it for wtx because that's just simply chain rule. So if you remember what the ReLU function looks like, it's simply if we have. So I'm just going to draw the x-axis. So this is x. So this is 0. This is x. Oop. Okay, so this is 0. This is infinity, and this is negative infinity. So what the ReLU function does is it says, well, if x is negative, then the slope, then it looks like this. So all negative values of x, if I plug in a negative x, ReLU will give me a 0 value. So this is 0. However, if I give ReLU a positive number, then it just gives me back the number itself. So it looks like this, right? So this slope is 1, right? So if this is 1, then this point right here is 1, 1, whatever. Yeah, that makes sense. So in class, what we've done is we've used what's called an indicator function that basically says when x is greater than 0, then we return 1, but this returns 0 if x is actually less than 0. If x is less than or equal to 0. And then finally, we just need to do dx of x because of chain rule, right? Because this is a function, so we calculate the derivative of the function and then distribute the derivative towards what you pass into it. So, with that in mind, if we have ReLU of wtx dx, this is equal to 1 wtx greater than 0 times d of dx of wtx. This is simply a linear equation. So the derivative of this we know is just w. And that's the derivative. So put that here. Okay, so the final objective that we need to figure out how to take the derivative is a quadratic. So this is a longer one out of all of the 4. So to do this, I'm going to use a small toy example. So let's just say x is equal to x1, x2, and a is equal to a11, a12, a21, and a22. So then writing this out, this becomes d dx of x1, oh, sorry. We're going to transpose it, so x1, x2, a11, a12, a21, and then x1, x2. So I'm going to skip a few steps and just write out kind of what this simplifies to. This is equal to d dx of, a11 x1 squared plus a12 x1 x2 plus a21 x1 x2 plus a22 x2 squared. So if we take the derivative of this with respect to x1 and x2, so first x1 we get 2a11 x1 plus a21 a21 x2, sorry, getting ahead of myself, a12 x2 plus a21 x2. And then with respect to x2, we get a12 x1 plus A21 x1 plus 2A22 x2. So that's the derivative with respect to x1 on the top and x2 on the bottom. So if we do some rearranging, well, this just becomes A11 x1 plus A12 plus A21 x2. Oh, I messed up right here. This should be x1. And then this bottom becomes, similar A12 plus A21 x1 plus, I keep messing up. Sorry, I messed the 2 at the top. 2A22 x2. So with that in mind, we could take out the x1 and x2. So this becomes, sorry, I need to keep these equals going. 2A1 1 plus A12 plus 2A21, and then A12 plus A21 plus 2A22, and then we took that x out, so we have x1, x2. Sweet. So yeah, the final thing we can do right here is we can just simplify what this is. So if you think about it, the diagonals, if you, we can just simplify this out to simply A11, A12, A21, 2, plus A11, A22, and we just need to transpose these, so A12, A21, times x1, x2. So if you notice, this is just A, and this is A transpose. So our final idea is we get d dx of xt ax is just simply A plus A transpose x. So it started as the last steps, and I kind of mumbled through it. But with this in mind, we now have our 3 derivatives. So I'm going to just move this up here. So now that we have all our derivatives, well, let's just simplify our equation. So we have d dx of f of x is equal to d dx of the L1 norm of x plus the L2 norm squared of x plus the ReLU of WTX plus the quadratic. Oop, I ran out of space again. The quadratic, ATX. And if we just substitute our values in here, we know that this this equation just becomes the sine of x plus 2x plus the indicator of WTX greater than 0, W plus A plus ATX. So now we just need to, since we're trying to plug A into this, we can now substitute our values. So we can substitute X for little a, and then also W and our matrix A. So this is equal to the sine of, what is A? A is 1, 1. So sine of 1, 1 plus 2 times 1, 1 plus 1 according to WTX, which is just 1, 0, 1, 1, greater than 0, right? Which, if we just do this out, this is just simply 1. So, yeah, and then 1, 0, plus, and then this is, we're going to need some more room for this. I have whatever A is plus AT times 1, 1, right? Because that's A. So we get 3, 2, 2, 1, and then since the diagonals are the same, off diagonals, then we get that. So if we just simplify this, we get, well, the sign of 1, 1 is just simply 1, 1. 2 times 1, 1 is just 2, 2. Well, 1 is greater than 0, so we just simply get W. That's 1, 0. And then if we sum these two HC's together, we get 6, 4, 4, 2. And then finally 1, 1. So simplifying all this out, well, this just is simply 6 plus 4, which is 10, plus 4 plus 2, which is 6, plus, and then all of this together is, the top is going to be 4, right, because 1 plus 2 plus 1, and the bottom is going to be 3. So we get a final answer of 14, 9. Sweet. And that's our final answer. Here, I'm going to write this better, actually. 14 and 9. There we go. Thank you.